Chapter 2 deals with functions, which you dealt with in Algebra 1, so hopefully this isn't completely new to you. Relations and functions. It gets a little bit more in depth than we did in Algebra 1, so just be prepared for that. Like I said in the last chapter, Algebra 2 happens in your brain, not so much in solving problems. So, the faster you learn that, the faster you will be at doing well in this class. So right off the bat in section 1, we're just talking about relations and functions, kind of reviewing some important ideas here. I have a grid with a bunch of vocab words. In Algebra 1, in algebra you will work with a coordinate system all the time. In Algebra 1 we learned all of these words, so here's the review. Key parts of the coordinate system we will use. This whole thing right here, this whole grid is the coordinate plane. The part that you see, and also the parts that you don't see. That plane extends in every direction forever. We just are showing this particular part right here, up to 7 and negative 7, 7 and negative 7. Where's the x-axis? It is the horizontal, the flat, is the x-axis. Which means that the y-axis is the vertical axis. Keep those straight. Keep horizontal and vertical straight as well. Horizontal is flat. Horizon, the horizon is flat. Horizontal axis is flat. Okay, origin, where's that at? That is where the x-axis and y-axis cross. So I'm going to put that on here. Where the x and y axes cross. The plural of axis is axes. It's not axes, axes. And that is the origin. All right, we've taken care of x-axis, y-axis, origin, coordinate plane. What's an ordered pair?
Like 1, 2.
Sure. 1, 2. Negative 3, negative 5. It's a point on the grid. Like if I put that point on there right there, the ordered pair would be an x-coordinate, comma, a y-coordinate. It's always the x-coordinate first, y-coordinate second. Later on in this class, we're going to start dealing with 3 variables, x, y, and z. If you were to graph it, that would be an ordered triple in a 3-dimensional space. So we're going to be working with equations, not graphing them. But if you were to graph it, that would be a 3D situation. So you have x-coordinate, comma, y-coordinate. So in this case, the ordered pair that I have here would be what? Negative 4, comma, positive 4. So that is the ordered pair. This being negative 4 right here, and this being positive 4 right there. So therefore the x-coordinate is what? I mean, in general, the x-coordinate is that one, and the y-coordinate is that one. So that was the coordinate plane. Now we're going to talk about a relation. In a relation, you basically are given a set of ordered pairs. The notation for a set is the squiggly brackets that you see here. The stuff inside those squiggly brackets is our relation, the set of ordered pairs. We need to remember what domain is. What is domain? No. No. Huh? No. No. The x-coordinates. All the x-coordinates that are involved in the relation are your domain, which means that the range is probably y-coordinates. Okay, so now that we know what the domain is, we need to write the domain of our relation that we're given here as a set. So I'm going to write squiggly bracket, D equals, D is for domain, what? 2 is a domain value.
5.
5 is also.
And how many is it?
Negative 1 is also, and that's it. Close your squiggly bracket, and that's your domain. For range, we're going to use capital R equals, open your squiggly bracket, and what are we going to write?
5.
Yeah?
Negative 2.
Yeah? And that's it. We have negative 2 again, but we're not going to repeat that negative 2. You don't write repeats when you're just listing the domain and range, like we just did. Okay, they're also going to ask you to set up a table or a mapping or a graph. And you need to know how to do all 4 of these total. These 3 plus what we just did. The table in this case is going to be x coordinates and y coordinates. So you're making an xy kind of like t-chart. You write down all of your ordered pairs as you see them for your x coordinates and y coordinates. In this case, you can write the repeats. In fact, you have to. So my first coordinates are 2, 5. So I write 2, 5. My second coordinates are 5, negative 2. So I write 5, negative 2. And then my third one's negative 1, negative 2. Just like that. If you look in the back of the book, they may have put those x coordinates in numerical order. That's fine. But the y coordinates go with the x coordinates. So if you did put negative 1 first up here, across from it, you would have to see that negative 2. They still match across. All right, make sense? Okay. So that's the table. For a mapping, this is the one where you write domain and range, and you make these ovals. We write down all of the domain values in the domain. It doesn't really matter what order you put them in. I'm just going to go as I see them as I read from left to right. So that'll be a 2, a 5, and a negative 1. You can put them in numerical order if you want to. I'm just writing them like that. Doesn't matter. It's a good question. For the range, I'm going to write the 5 for this one, the negative 2 from this one, and then I have a negative 2 again, and I am not going to write that repeat. The reason you don't write repeats in the mapping is because you're about to draw arrows and you want to see visually where those arrows are going and if they are going to or from a repeated number. So no repeats on the mapping. All right, now we draw arrows. I don't know how that just happened. Now we draw arrows. So I go from 2 up here to 5. So I go from 2 to 5 on my map. If I have a coordinate of an x coordinate of 5, that corresponds with negative 2. So on my map, I go from 5 to negative 2. On the last one, I start at negative 1 and I wind up at negative 2. So I go from negative 1 to negative 2. And you can see how those two arrows came to the same number. That's why we don't write repeats. We want to see that if there's going to be arrows going to more than one number or not. Okay? That's your mapping. Basically what this says is if I have an input, so let's put for domain, it's the inputs. And for range, it's output. If I have an input, that's like if I have a machine and I put something into the machine does some stuff and it spits out a result. The range are the results. So this is what I put into the machine, this is what I get out of the machine. Input, output. If I put 2 into this relation machine, I get a 5 back. If I put 5 into this relation machine, I get a negative 2 back. If I put negative 1 into the relation machine, I get a negative 2 back. Okay? Finally, the graph. This is easy. You guys know how to do this. Basically, you're just plotting order of pairs. You have a 2, 5, so 1, 2, 3, 4, 5. You have, let me label that, 2, 5. You have 5, negative 2, so 1, 2, 3, 4, 5. And then negative 2 is right there. Label that. And then negative 1, negative 2 is right there. Label that. So that's 4 ways that you can represent a relation when you're given a relation as it was given to you. separate out the domain and range, list them in a table of values, draw a mapping diagram, graph using ordered pairs on a coordinate plane. Do we write repeats in the domain and range when we have them separated out? No. Do we write repeats in a table version? Yes. Do we put repeats in the mapping? No. Do we put repeats in the graph? Yes, you do. So you need to know that. Make sure you make a note of that in your notes. So we have this relation. What is the next thing to do? D equals? Squiggly bracket. Good? Yeah. Yeah. Good, we're not repeating that -3. Okay, as a table, somebody else. X and Y. Yeah. Yep. Good. Mapping, what do we do? Somebody else. These are called ovals. Yeah? You are you still. Okay? Somebody else. That's it? Okay. Now what? I like changing colors. So 4, 2. Good. 3, 2. Okay. -4, 2. And? Good. It's okay to have your arrows crossed in this mapping diagram. Don't be afraid to cross them. Don't draw your arrow way around here. You don't have to do that. Just straight arrows through this little area here. Okay? And finally, the graph. We know how to do that, I'm sure, so I'm just going to go ahead and graph these. +4, -3 is there. Label them. And then 3, 2, and then -4, +1, and 0, -3. On these graphs, you guys label those ordered pairs. Okay? I'm not going to do it here just for time. Okay. Problem like this looks like it's probably pretty complicated because you see like more than 2 words here, but it's not that big a deal. Just read the problem, figure out what it's asking you to do, and then do it. The monthly average water temperature of the Gulf of Mexico in Key West, Florida varies during the year. No kidding. In January, the average water temperature is 69 degrees Fahrenheit. In February, it's 70 degrees Fahrenheit. In March, it's 75 degrees Fahrenheit. In April, it's 78 degrees Fahrenheit. In May, it's probably going to be warmer than that still. Represent this relation in 4 different ways. So what is this asking you to do? Make a graph, XY table, a mapping, and then write the domain and range. So the first thing we probably should do is write down this as a relation. Okay? So that means I need a squiggly bracket. And then I'm going to write down all of my what? All my what? As, how am I going to write them? Okay. So what could I write? Good. 1. That's being understood as a month, and 69, which is understood as a temperature. Okay? We need to know that. This relation doesn't, though. So I'm just going to write squiggly bracket 1, 69. Yeah, we need to put parentheses around those also. These are ordered pairs, then comma, then your next ordered pair, which will be 2, 70. And then your next ordered pair, which will be 375. And then, do we have another one? 478. Close your squiggly bracket. So there's the relation. Now we got to represent it. Okay, XY table. Probably going to write what here? And? Okay. It says represent this relation in 4 different ways. We already have one right here. Mapping. One, two, three, four. Range. Okay. Arrows. Straight across, right? There are no double ups here. So those arrows go straight across. That's your third way to represent this. Fourth way would be, since we don't have a graph here, let's do the D equals and the R equals. What is the domain? And the range? Okay, so that's probably a little cheating there. Technically, this is one of the ways to do it. Technically, you're going to be given this. So then the 4 ways that they're looking for would be the table, the mapping, splitting it into domain and range, and then the 4th one would be the graph. Since I don't have the graph here, we're going to skip the graph. Okay? Okay, vocab. We have 2 types of variables, independent and dependent. What is an independent variable? Independent is the thing we control, the variable. Keep walking. The variable we control. Which variable is that? Usually. Usually the x variable. Does it have to be the x variable? No. But typically, we're working with x and y, and in that case, then, it's understood that the x variable is the independent variable. Anything else we can say about the independent variable? The independent variable is the input. The thing we control is the thing that we change. That's what we plug into the function machine. Yeah? Yeah.
What do we know what the output is?
The function will tell you that if you're dealing with a function. If you're dealing with a relation, you might not have a definition for an input of 1. Okay? So knowing now what an independent variable is, what is the dependent variable? Okay, I heard output first. And the thing that we don't control. In other words, sure, the thing that we measure. I like that. Yes.
What's a better word for saying?
I like thing, but fine. Variable. And then I also heard usually the y variable. Okay, so it's not always obvious which one is which, especially if you're dealing with a word problem. It's up to you to figure that out. So let's take a look at these 2 statements here and see if we can figure out which one controls the other. In other words, which one is the independent variable and which one is the dependent variable. So we have the air pressure inside a bike tire increases with the temperature. Maybe you knew that, maybe you didn't, but this is a true statement. As the temperature changes, the air pressure inside a tire will also change. Which variable is the independent variable here? What about the air? We have air temperature and we have air pressure. Which one are you talking about? The temperature of the air outside changes the air pressure in the bike tire. So the air temperature is the independent variable, and the air pressure is the dependent variable. On a hot day, if you fill the tire on your bike and then check the air pressure on a cold day with no leaks, the pressure in your tire will be different. It's because the air temperature has changed. As snow melts off the mountain, the Bighorn River rises. Which one is the independent variable here? The snow melting causes the Bighorn River to rise. Can the Bighorn River rise without snow melting? Yes. But in this case, the snow melting caused the river to rise. So the river rising, dependent. Yes. We have three graphs. Analyzing graphs is a very important part of Algebra 2. It's a very important part of the ACT test in both math and science. So it's important to understand how to do this. Look at the shape of the graph. The shape of the graph will sort of tell its own story. What I want you guys to do with this is to tell a story for each of these graphs. We have three. Pretend that you are driving to school. Notice what's on the x-axis and the y-axis, and then come up with some sort of story that makes this make sense. Change in income. We have time and income. What would cause this sort of graph? Come up with a story for each of those cases. Number of birds over time. So as time goes on, we have a bird population. What's going on here? Come up with a story for all three, and we'll talk about them here in a second. All right, moving on. A function. What is a function?
Isn't that like
You plug something in, so you put something in.
So it's like a 3 T-chart thing, and it's like you start with, then it's your function, and then it has like if you add 2 plus 4.
I'm going to go a little more formal than that, and I'm going to say that a function is exactly one output for each input. What that means is if I plug something into my function, I will get exactly one thing out. If I plug something different in, I will get exactly one thing out. That something different that I get out might be the same as the first output that I got, but I will not get more than one output for any input that I try in my function. If I do, then it is not a function. In order for a relation to be a function, then only one output for each input. If it's not, then it's not a function. How do you tell a relation is a function with ordered pairs? No repeated x values. If I have a repeated x value, then that means that I plug in that x value and I get one particular output. I plug in that other x value and I get a different output, but those two x values were the same. That goes against what I said here. Exactly one output for each input. I take an input and I plug it in and I get two outputs. That is not a function. Table. No repeated what? X values. Can I have more than one output be the same? Can I have an output that is repeated? Yes. I can't have an input that is repeated. Hang on. For a mapping. Well, we don't write repeats on mappings, though. No arrows. I like that start. But it's going to be from a number in the domain. As long as you're doing the mapping correctly, meaning you're not writing the repeats, then you'll have no arrows coming from the same number in the domain. And from a graph, how do you tell if a relation is a function? Passes vertical line test. We'll We'll talk about vertical line tests here in a little bit. Okay, so we have is each relation a function. Each one of these, by the way, is different. Let's go across the top. We have a set of ordered pairs. You need to know how to decide if something's a function from a set of ordered pairs, which means we're looking at the what? X coordinates, and we need to see if there's repeating or not. Do we have repeated X coordinates here? No, so then therefore this is a function, yes. Okay, now we have a table of values. What are we looking for here? Repeating X values, do we have any? Yeah, these two ones right here are being repeated, so is this a function? No. We have a mapping sitting here. What are we looking for on the mapping? No arrows coming from the numbers in the domain repeated. Do we have any repeated arrows from any of these numbers? No, we don't. So therefore, this is a function. And how about the last one? What do I have to do to check to see if that is a function? The vertical line test. So I'm going to take my vertical line here, and I'm going to pass this vertical line over my function. If I see my function touching that vertical line at any time, more than once, then it's not a function. Does that happen here? No. At any given time, my vertical line is only touching my function once. Therefore, the answer here is yes. Okay, we're almost out of time, so let's quickly do these bottom three. Function or no? No, we have repeated 4s. Function or no? Yes. Function or no? No, because of these arrows right here coming out of that 1, both of them are leaving from that 1. This one is no, and if I pass my vertical line over, this is also no. In this region right here, I'm hitting it 3 times. Over here, I'm also hitting 3 times. Doesn't matter. I hit more than once, so the answer here is no. You guys can do 8 through 16 all as homework tonight. We'll finish up the section next time, and then you can turn the assignment in completely next time after that.